Alright, so welcome to the next episode of SAT Math. Today we're gonna keep solving college Panda. Today is test number 5, section 4, and we're gonna solve question from 14 and to 18. So 5 questions in a row. So let's go. Number 14. So a coal processing plant can process 90 tons of coal per minute. 3 trucks can deliver 135 tons of coal per hour. What is the minimum number of trucks necessary to keep up with the plant? Okay, so let's calculate it how many. Okay, so for this type of question, we should convert everything to the same unit, and we're gonna calculate from there. So here we have that process. Plant can make 90 tons per 1 minute. So this is equivalent with how many? 90 times 60, right? Tons per hour, right? Very straightforward, right? Right, so this plan is actually, let's calculate that. So that this plan is actually 5,400 tons per hour, right? So we're gonna leave it as 5,400 tons per hour. So 3 trucks. So okay, 3 trucks gonna deliver how many? 135, right? 135 tons per hour, right? So we can see that. Number of trucks, right? So number of trucks gonna be 5,400 divided by 135. And multiply by 3. You can see because we have the 3 trucks to deliver 135 tons per hour. So this is the number of trucks, right? And maybe we're gonna have to round it up. So let's calculate it. That's gonna give us 120. So 120. So the answer should be D, right? Okay, let's do number 15. So number 15, we know the equation for a circle. So we know that the center is 2 and minus 3. So the equation for so if the center of a circle is AB and the radius is R. Right? So the equation gonna be x minus a squared plus y minus b squared equal to r squared, right? So that's the equation of the circle. So now we have the center to be center of us gonna be 2 minus 3. So we know that a is equal to 2 and b is equal to minus 3. So we can replace that into the equation. So a is equal to 2 and b is equal to minus 3. So we put minus 3 in here, equal to r squared. Okay, so that's fine. Now we know that circumference is gonna be equal c is 25, and that we know it is 2 radius times pi, right? So we know that pi is gonna be radius gonna be equal to 10, right? So with that in mind, we just have to substitute everything inside here. So x minus 2, okay, y minus 3 is just y plus 3, and r we're gonna substitute with 10, right? So that's equal to 100. So we can clearly see the answer for this question is C, right? 15 should be C. Alright? Alright. Okay, so now let's do number 16. Okay, so we know that f of x is equal to x cubed plus 2, and g of x gonna be 2x, right? 2x. So we know that f of b, okay, okay, so for this one we have C, right? For 15 we have C, right? 15 is C, so I have to mark it. 15 is C. Okay, so let's do 15 is C. Let's do number 16. I forgot what is number 14. We're gonna recalculate it. Don't worry. So let's see. Let's zoom in. Let's see if we fix it. Ah, we lost. Jesus Christ. Okay, don't worry. We're gonna fix this again. Let's say 15. Don't worry, we're gonna fix it again. So okay, so we know that f of b is equal to 29. For 16, we know f of b equal to 29, which means that b cubed plus 2 is gonna be equal to 29. And you can easily even show b is equal to 3, right? Just put in 3 cubed is 27 plus 2 is 29, right? So we know that g of b gonna be g of 3, so that is gonna be 2 times 3, so it's 6, right? So g of b is 6, so 16 gonna be b, right? 16 gonna be b. So I want to use the marker here. Okay, so let's move on to number 17. So they asked us to sum these two polynomials. Okay, so we asked number 17, we asked us to sum this polynomial. So you can see x squared y. There's no other term in the x squared y, so this one gonna be kept. X y squared, this one gonna be also be kept because there's no x y squared anywhere. So we know that for a fact. So in the sum of these two polynomial, it has to has x squared y and xy squared. So x squared y and xy squared, and it has to be 4x squared y plus 2x y squared because it has to be that way, because there's no other term with these x and y value. So we can cross out c and b. So it's a and b left, and we know that 3 x squared y squared minus 5x squared y squared, and then release we're gonna return minus 2 x squared y squared, right? So 17 is simply a, right? A. Alright, so number 16. Researchers attempt to model the growth of the recovering hawksbill turtle population in East Africa. Estimated the population to be 200 in the first year. In the second year, they record a population of 600. Okay, how much greater would the estimated population be in the third year if the turtle population growth were exponential rather than linear? Okay, this is an interesting hard question. We're gonna have to sit down and think. Okay. So first of all, we know that 17 is A, so 80. Okay, so let's think about number 18 a little bit. Expand this, right? Place to right. Okay, so let's think about these two models, which is the linear growth and the exponential growth, AT. So if this was the linear growth, so it's gonna be y equal to ax plus b, right? So this is linear growth, right? So in here we have it x equal to 1 because it's first year. Then we know that y gonna be 200, right? Okay, so and we also know that if x is equal to 2, it's the second year, then we know that y gonna be 600, right? So from these two, we can solve out for a and b. We can solve for a and b, and we can solve from these two. We have equation like this. So 200 equal to x plus b, and we know that 600 gonna be equal to okay, so because we know that now it's a plus b, x is equal to 2, so it's 1a plus b, a times 1, so this is a times 2 because it's a times x plus b, so this is just a plus b, and under we have 2a plus b because we replace x with 2. Okay, so we have system equation a plus b equal to 200 and 2a plus b equal to 600. Alright, and 2a plus b equal to 600. Plus b, right? So if we subtract equation 2 for equation 1, okay, so we're going to call that equation 1. I want to call that part equation 1. So we do it again. This is equation 1. Okay, so drag it down here. Okay, we call it this equation 1. So let's delete this part from here. Okay, that's very good. So now if we subtract equation 2 for equation 1, so subtract equation 2 for equation 1, we're gonna have 400, because 600 minus 200 is 400. So b minus b is 0, and 2a minus a is a. So a is 400, right? So that's something wrong already right there. Okay. So you can see. So we can solve. So we know that b gonna be minus 200. So we can see that this is kind of wrong, right? Okay, so it's okay. So okay, we can solve for a and b. So now we know that y is gonna be 200, 400. So we substitute a with 400 and b with minus 200. So y is gonna be 400x minus 200, and we know that we have to calculate it for x equal to 3, because it's in the third year. So we can figure out y equal to 400 times 3 minus 200. So 400 times 3 is 1200 minus 200, so that's 1000, right? So that's the linear growth. So for the third year, the linear growth gonna give us 1000. So first of all, remember that point. For the linear growth, for the third year, we have 1000. All right. And now let's say let's try exponential growth. Exponential growth. Exponential growth. Okay. Let's try it back to something like this is okay. Let's just change it to black. Okay, so exponential growth means that y equal to a to the power of x, right? Okay, maybe time a constant b, right? Time a constant b. So so for the first year, x equal to 1, we know that y equal to 200, right? So same thing, y equal to 200. So we know that 200 is equal to a to the power 1 plus b times b, right? So that's a times b, right? Okay. So now we know that also x is equal to 2 and y is 600, right? Equal to 2, then it's 600 here. So it's 600 equal to a to the power of 2 times b, right? So it's a squared, right? So now we can divide it both sides. So we have two equations. So 200 is equal a times b. 600 is equal a squared times b. Alright, so if we call this also 1 and this also 2, right? It's 2. So if we take 2 and divide it by 1, we're gonna get 3 equal to a, right? 3 equal to a, and so we have b. So b gonna be equal to 200 over 8, so it's 200 over 3, right? Right? Alright, so now we have the answer. So we have y to be equal to, so we have y gonna be equal to a which is 200, a is 3 times x, 3 to the power of x, right? And times 200 over 3. Alright, like that. It's very good. Very good. So now let's calculate x equal to 3. So y gonna be equal to 3 to the power of 3 times 200 over 3, right? So that's 3 to the power of 2 is 3 to the power of 2 times 1000 times 200, and that's gonna give us how much? Is 9, 1800. So the question here, so we have the number of 1800 here. So they ask us how much greater. So the difference is obviously 800, right? So 18 is obviously 8. Right, so 18 is 8. Okay, so let's check it out for number 14. Number 14, let's recalculate number 14 up here. Okay, so number 14. So a core processing plant can process 90 tons per 1 minute, right? 3 trucks can deliver 135 tons per hour, per 1 hour. So what is the minimum number of trucks necessary to keep up with the plant? So this is gonna be equivalent with 90 tons times 60, and this is for 1 hour, right? So this is gonna be 5,400 tons per hour, right? Correct. So number of trucks gonna be, because we have a multiple of 3 here, so 3 times, so 5,400 divided by 135, and the answer is 120. So the answer is going to be D, right? D. Alright. So let's check it out. 14 is D, 120, okay. 15 is C, alright. 16 is B. Okay. 17 is A, and 18 is A. So everything is correct. So that's enough for this session. So thank you very much. Have a good day, and we're gonna see you on the next session. Goodbye.